Introduction. Welcome to our channel. Today, we will dive deep into a topic that has become increasingly crucial in the world of artificial intelligence and machine learning: building a scalable AI model deployment pipeline. As organizations increasingly adopt AI solutions to enhance their operations, the ability to efficiently develop, deploy, and manage AI models in production becomes paramount. In this video, we will guide you through the entire process, from the initial stages of development to the final deployment in a production environment. Whether you're a data scientist, machine learning engineer, or someone just curious about AI, this discussion will provide you with valuable insights. What is an AI model deployment pipeline? Before we jump into the specifics, let's clarify what we mean by an AI model deployment pipeline. Essentially, it's a structured process that facilitates the transition of machine learning models from development to production. It encompasses various stages, including data collection, pre-processing, model training, evaluation, deployment, and monitoring. A well-designed pipeline ensures that the model can be easily updated, scaled, and monitored, making it more reliable and efficient. The importance of a scalable pipeline. In the realm of AI, scalability is key. As the demand for AI applications grows, so does the volume of data and the complexity of models. A scalable pipeline can handle increased workloads without compromising performance or reliability. This allows organizations to adapt quickly to changing requirements, deploy new models, and incorporate user feedback. Scalability also means that the pipeline can accommodate various types of models, whether they are simple linear regressions or complex deep learning architectures. Step 1: Data collection and pre-processing. The first step in our pipeline is data collection. This step is foundational because the quality and quantity of data directly impact the model's performance. Depending on your application, data can come from various sources, including databases, APIs, and web scraping. It's crucial to gather diverse and representative datasets to train your models effectively. Once you have collected the data, the next step is pre-processing. This involves cleaning the data, handling missing values, and transforming it into a format suitable for model training. Common pre-processing techniques include normalization, one-hot encoding for categorical variables, and feature scaling. In this stage, it's essential to document the pre-processing steps you've undertaken, as this will be important for reproducibility later in the pipeline. Step 2: Model development. With clean data in hand, we move on to the model development phase. This is where the magic happens. Depending on your problem statement, you'll choose an appropriate algorithm. It could be traditional machine learning techniques like decision trees, random forests, or support vector machines, or you might opt for deep learning architectures like convolutional neural networks and recurrent neural networks. During this phase, it's also essential to focus on hyperparameter tuning. This process involves experimenting with different parameters to improve the model's performance. Automated tools like grid search or random search can help in this regard, allowing you to identify the best performing parameters efficiently. Furthermore, integrating version control systems like Git during model development can help track changes and collaborate effectively within a team. Each model iteration should be versioned to ensure that you can roll back to a previous version if needed. Step 3: Model evaluation and validation. Once you've developed your model, the next critical step is evaluation and validation. This phase ensures that your model generalizes well to unseen data. You'll typically split your dataset into training, validation, and test sets. Using various metrics such as accuracy, precision, recall, and F1 score, you can assess how well your model performs. It's also important to implement cross-validation techniques to ensure that your model is robust. This process involves partitioning the training data into multiple subsets and training the model multiple times to minimize overfitting. In cases where model interpretability is essential, tools like SHAP, Shapley additive explanations, can help you understand the model's predictions. Step 4: Deployment strategy. Now that you have a validated model, it's time for deployment. But before you dive in, you need to consider your deployment strategy. There are several ways to deploy your model, including 1. Batch processing, ideal for applications where real-time predictions are not required. The model processes data in batches at scheduled intervals. 2. Real-time serving. This approach allows the model to serve predictions in real time using APIs. Frameworks like TensorFlow Serving or FastAPI can help implement this. 3. Edge deployment. In cases where latency and bandwidth are concerns, deploying models on edge devices can be advantageous. Choose a deployment strategy that aligns with your application's requirements and user expectations. Step 5. Containerization and orchestration. To ensure that your model operates smoothly across different environments, consider containerization. Docker is a popular tool for this purpose, allowing you to package the model and all its dependencies into a single, portable container. This ensures that the model runs consistently across various environments, reducing the "it works on my machine" problem. Once containerized, you might want to look into orchestration tools like Kubernetes. These tools manage container deployment, scaling, and networking, making it easier to handle multiple instances of your model and ensuring high availability. Step 6. Monitoring and maintenance. After deployment, the work is far from over. Continuous monitoring is crucial to ensure your model performs as expected in the production environment. This involves tracking key performance indicators, KPIs, such as latency, throughput, and model accuracy. It's also important to monitor for data drift. Over time, the data your model encounters in production may differ from the training data, which can lead to decreased performance. Implementing an automated retraining pipeline can help address this issue. This means regularly updating your model with new data to maintain its accuracy and relevance. Additionally, logging and alerting mechanisms should be in place to catch any issues early. Tools like Prometheus for monitoring and Grafana for visualization can be incredibly helpful in this regard. Step 7. Iteration and feedback loop. In the world of AI, the deployment of a model is just the beginning. Establishing a feedback loop is critical for continuous improvement. Gather feedback from users and stakeholders to identify areas where the model can be enhanced. This might involve adding new features, optimizing algorithms, or incorporating more diverse datasets. Establishing an iterative process allows you to refine your model continually. By treating model development as a dynamic process rather than a one-time event, you can adapt to changing requirements and improve performance over time. Technologies and tools. As we discuss the pipeline, it's essential to highlight some of the key technologies and tools that can help streamline the process. For data collection and pre-processing, libraries like Pandas and NumPy are invaluable. For model development, TensorFlow, PyTorch, and Scikit-learn are excellent choices. When it comes to deployment, Docker and Kubernetes are industry standards. You can also consider cloud services like AWS SageMaker, Google AI Platform, or Microsoft Azure ML, which provide comprehensive solutions for deploying and managing machine learning models. Finally, for monitoring, tools like MLflow and Kubeflow offer robust options for tracking experiments, deployment, and model performance. Conclusion. To wrap things up, building a scalable AI model deployment pipeline is both an art and a science. From data collection and pre-processing to model development, evaluation, deployment, and ongoing monitoring, each step is integral to ensuring that your AI models perform effectively in real-world applications. The key is to design a flexible pipeline that can adapt to changes and scale as needed, allowing you to respond to the evolving landscape of AI technology. Thank you for joining us today. We hope this comprehensive guide helps you in building your own AI model deployment pipeline. If you found this video helpful, please give us a thumbs up, subscribe to our channel for more content on AI and machine learning, and leave your questions and comments below. We'd love to hear your thoughts and experiences with AI model deployment. Until next time, keep innovating and exploring the incredible world of artificial intelligence.